AI video generation has just completely exploded onto the scene, right? It's creating these mind-blowing visuals from just a few words. But so many of these incredible creations have felt like, well, like something was missing. They've basically been silent movies. Well, guess what? The silent era of AI is officially coming to an end. So how exactly do you teach an AI to hear what it sees? Let's dive into the fascinating research that's making it all happen. I mean, just look at this. You can almost feel the heat coming off that forge. You can see the effort in the work. But to truly be there in that moment, you need to hear it. That sharp clang of the hammer hitting hot metal, the hiss of the sparks. And that is the goal here. To move beyond these silent AI clips and into these rich, multisensory experiences where what you see is perfectly, and I mean perfectly, coupled with what you hear. Now, there's an official name for this challenge, of course. It's called Text-to-Sounding Video Generation, or T2SV for short. And you've got to understand, this isn't just a simple feature upgrade. It's the next major frontier in creative AI. It's a really crucial step toward an AI that can generate a digital world with the same sensory richness as our own. But, and this is a big but, getting this right is deceptively complex. You can't just, bolt a video generator onto an audio generator and hope for the best. The researchers behind this new model called BridgeDiT, they pinpointed two fundamental hurdles that have been holding this whole technology back. Okay, so first up, there's what they call the conditioning problem. This is what happens when you feed a single text prompt to both the video AI and the audio AI, and they just get confused by details that aren't for them. The second major issue is the interaction problem. This means that even if you have good instructions, the two AI models need a way to actually communicate and sync up their work in real time. And this quote right here, it perfectly explains that first problem. Imagine your prompt is, a red car emits a sharp honk. Okay, well, the part about the sharp honk, that's just noise to the video model that's trying to draw a car. And the word red, that's totally useless info for the audio model trying to create a sound. It's literally like giving a single recipe to both a chef and a musician. Each one is just confused by the instructions meant for the other person. So, how do you solve this mess? Well, the first step is pretty logical. You have to stop giving the AI mixed signals. You need to create separate, crystal clear instructions for what to see and for what to hear. And this brings us to the first really brilliant innovation in this research, a system they call Hierarchical Visual Grounded Captioning, or HVGC. It's a bit of a mouthful, I know, but just think of it as an expert producer who writes two completely different scripts, one for the visual effects team and another one for the sound design team. So here's how it works in 3 simple stages. First, a really powerful vision language AI watches the source video and just writes this super detailed description of everything that's happening. Then, a second AI acts like a filter. It reads that description and pulls out only the concepts that would actually make a sound, like hammer or sparks. And finally, a third AI uses that visual context and those sound concepts to write a pure audio-only caption. And this diagram, it just brilliantly illustrates the whole pipeline. By starting with the visuals, the system makes sure that the final audio description, something like the resounding clang of a heavy hammer, is directly grounded in what's actually happening on screen. And just like that, the conditioning problem is solved. Each AI model gets a pure, dedicated script it can understand perfectly. Okay, so the models now have these beautiful, clean instructions, but that's only half the battle, right? How do you make sure the clang happens at the exact moment the hammer strikes? They still need to work together. This is where the second huge innovation, the BridgeDiT architecture, comes into play. You can literally think of it as a structural bridge built between 2 separate towers, one for video and one for audio. It's like it connects 2 expert artists, a painter and a composer, and lets them collaborate on a single masterpiece. The secret sauce inside this bridge is a mechanism called dual cross-attention, or DCA. Now, the crucial thing to get here is that this is not a one-way street. It allows for a symmetric, two-way conversation. The video model can ask the audio model, hey, what are you doing at this exact millisecond? And the audio model can ask the exact same thing right back. So here's a look at the full architecture. You can see on the left and right, you've got the 2 parallel streams for video and audio. But the magic? That's happening right there in the middle, with these crucial BridgeDiT blocks. You can think of these as the communication hubs, where the 2 models are constantly exchanging notes to sync up their work. And if we zoom in on one of those blocks, you can see the dual cross-attention mechanism in action. See how the information is flowing in both directions? The AI's internal idea of the video is influencing the sound, and at the same time, its idea of the sound is influencing the video. This constant two-way feedback loop is the key to finally solving that interaction problem and getting perfect synchronization. So, we've got a clever way to write instructions and a really smart architecture for communication. But does it actually work? Let's take a look at the results. The researchers tested this system rigorously, and the results, well, they're pretty impressive. This chart shows a key metric for audiovisual alignment, which is basically how well the sound and video match up. The previous best method is there on the left, and on the right, that's BridgeDiT, scoring significantly higher. It's a major leap forward in getting the timing just right. But honestly, here's the real proof. On the top, you see the video frames of the blacksmith, and on the bottom is what's called a spectrogram. It's a visual of the sound. Now look closely. Every single time the hammer makes impact in the video, you see a corresponding bright spike in the audio right below it. That is perfect synchronization. So what's the big takeaway here? This isn't just about making cooler videos. By solving these core challenges, these researchers have taken a massive step toward building an AI that experiences the world more like we do, through multiple senses, all at once. Ultimately, by taming text-to-sounding video, we're not just giving AI a voice. We're giving it a deeper understanding of cause and effect, a world where actions have consequences you can both see and hear. This breakthrough really does open up a whole new world of possibilities for creative expression, for virtual reality, even for scientific modeling. And it leaves us with a pretty fascinating question. Now that AI's eyes and ears are finally working in harmony, what sense will we teach it next?